Greetings of the day, dear students. In this video, we are going to discuss about the types of distribution system. By the time we complete this video, we will see what do you mean by primary distribution, what do we mean by secondary distribution, and also according to the shape of the system, again how this distribution network is classified into three types, mainly radial distribution system, ring or loop distribution system, grid or interconnected distribution system. In this video we will also discuss what are the advantages and disadvantages we are having in each and every category. Dear students, before watching this video, we have already completed the generation part and transmission part, right? And also now here with respect to the distribution, if you observe this diagram, the secondary transmission system is going to get terminated just before the substation. Up to here, this part of area we can consider it as a secondary transmission, and from this substation area to distribution substation part, this one will come under the primary distribution, where here the 33 kV voltage will be stepped down to the 11 kV voltage, and now this 11 kV lines will be running along the side. 11 kV lines will be running right. This 11 kV lines will be running along the road side. Now this 11 kV lines will be of three-phase 3-wire system. They will be of three-phase 3-wire system. Again, at distribution substation, this 11 kV voltage will be stepped down to 400 volts. Now from distribution substation to the consumer premises, that area will come under the secondary distribution. Here, for example, dear students, if the consumer's load demand is greater than some 50 kilowatt, instead of stepping it down to 400 volts, directly they will be given the 11 kV feeder line into their premises. Depending upon their load requirement, and they will select the transformer size and they will step down as per their requirements, right? Yeah. So but whereas in here with respect to the secondary distribution, where this 11 kV is stepped down to 400 volts, now this will be transferred or carried to the consumers with the help of three-phase 4-wire system. This 400 volts indicates the line voltage, that means in between any two lines. For example, if you are having three lines R, Y, B, this 400 volts is the voltage in between any two lines. So V line to line, that value is 400 volts. For example, if you want phase voltage, here you will be also having the neutral fourth wire, right? And the phase voltage will be line voltage divided by root 3. That much will be the magnitude of the phase voltage. So for example, in between two lines, if the voltage is 400 volts, now the phase voltage, that means in between the phase and the neutral, it will be 400 divided by root 3. That is the phase value. If nothing is specified, that voltage is called the line voltage. How do you understand the line voltage? In the sense, it is in between any two lines. It can be in between VRY or VYB or VBR. In between any two lines, the voltage will be 400 volts, right? Yeah. So this is about the primary distribution and secondary distribution. Now, dear students, here the same distribution network, depending upon its shape of the system, we can classify them as radial distribution system, ring or loop distribution system, grid or interconnected system. Each one is having its own advantages and disadvantages. Let me discuss those things. With respect to the radial distribution system, dear students, from substation, if this is the substation, from substation they will extract the feeder. This thick line is called the feeder. Depending upon the load areas, to which area they want to serve the load, feeders will be extracted from the substation. Now from this feeder again one more line will be tapped. One more line will be tapped. T-A-P-P-E-D, tapped. Right? So here this is the distributor. Now on the distributor the loads will be applied. For example, this will be the scenario if it is a DC distribution system. If it is a AC distribution network, AC distribution system, from substation again here also we will have the feeder. OAC indicates the feeder. OAC is the feeder. Now from this feeder, on this feeder one transformer will be there, distribution transformer, where this distribution transformer will step down the voltage to 400 volts. This is important. The 11 kV or 11,000 volts, 11,000 volts is stepped down or will be stepped down to 400 volts with the help of a transformer. This is the symbol for the transformer. Now on the secondary of the transformer we will extract the distributor. This wire is called the distributor. On distributor we will apply the loads. If you observe, this feeder is fed only from one substation. We are not having any some other substation far away, and we are not taking any some other feeder and connected to this transformer. Just if you observe the figure, the path of power flow is from top to bottom, from here to here. The path of power flow is from top to, from here substation to the load. There is only one single path. For example, if any problem or if any abnormal condition arises, or if any fault has occurred, if any electrical fault has occurred on this feeder, the entire supply to this loads will get disturbed, because there is no another way or path to provide the electrical supply to this load. If there has occurred any fault or abnormal condition on this feeder or substation, so this is the drawback. The customers will get affected, continuity of supply will get affected, reliability will be low. But what is the advantage? Its advantage is it is simple in operation, it is economical, right? It is easy to maintain. So these are the advantages. But what is the drawback? The continuity of the supply will get disturbed if any fault or abnormal condition has arisen. Clear? Yeah. Now, in order to overcome that, we are having a ring or loop distribution system. Ring or loop distribution system. Here, what happens is, observe dear students, this is the substation, but this is the entire feeder. S, L, M, N, O, P, Q, R, S. This forms in the form of a loop. For example, on this area, in this area, if any fault has occurred, instead of power coming from S, L, F, M to load, this is the path for power flow. If any abnormal condition or fault has occurred on this path, now the power can be transferred or delivered using this path. S, R, O, P, Q, N, and like this it can be served. So continuity, reliability will be more, it is more reliable, and also voltage fluctuations will be less. But the difficulty is, it is difficult to design compared to the radial system. Advantage is, if any one section, on any one of the section, if fault has occurred, through another section, through another path, the power can be supplied. But here also observe dear students, this entire loop is served only from one substation. We are not having any some other substation far away from that, where this substation is serving this loop. No, it is not like this. It is being fed only from one substation, right? Yeah. Obviously, because of this type, it also requires less conductor material is required. because less conductor material is required. You can observe here, less conductor material is required. Each part of the ring carries the less current in the radial system. Now the third type is the grid or interconnected distribution system. Dear students, here what happens is the feeder here, this is the feeder we are having. Three terminologies are important, dear students. One is the feeder, distributor and service mains. From top to bottom the size will get reduced. Less thickness wire is enough, right? Yeah. So here DC, DPC, OB, RA, OD. This is one loop. Now this loop is being fed from or being supplied power from two different substations. This is substation 1, this is substation 1, this is substation 2 at some other area. If any abnormal or fault or any maintenance problems occurred on this substation, the loads connected on the system will not get disturbed. They will be fed, or this network power will be supplied from the substation 2. That is the advantage. Continuity of the supply will be more, reliability will be more, quality will be more, quality of the service is improved, losses also will be less, efficiency will be more, losses will be less, efficiency will be more, quality, power quality will be good. But the drawback, but the difficulty is, it is difficult in planning, designing and operation. It is difficult in planning, designing and operation, and the initial cost is also more. These are the four problems we are having. Initial cost is more, planning is difficult, designing and operation is difficult. So this is the grid or interconnected distribution system. But what is the advantage, dear students? Continuity of the supply will be there, continuity, reliable, efficient, low losses, power losses, low losses, all these are the good quality. Quality is good, quality is good. Which quality? Power quality. Power quality means with respect to the voltage, rated voltage, frequency, harmonics, all these are the different parameters which can decide the quality of the power. Of course there are so many other parameters also, but mainly it should be at a rated voltage, without at a rated frequency and without any harmonics, without any interruptions. All those things are to be maintained. Yeah, so this is what all about the, dear students, types of distribution system. Primary and secondary distribution we are having. Transmission part we have already covered in the previous video, right? Depends upon the voltage levels. Voltage levels are important. If it is primary distribution, 3 phase 3 wire. Secondary distribution, 3 phase 4 wire. Here 33 will be stepped down to 33 kV will be stepped down to 11 kV. Here 11 kV will be stepped down to 400 volts. This 400 volts is between two lines. If somebody asks you what is the phase voltage, the phase voltage will be line voltage divided by √3. That one will be the phase voltage. Clear? Right. Thank you.